Come light it up, I'm ready to go. Come light it up, come light it up, I'm ready to go. Come light it up.
Thanks for the handoff, Monica. Appreciate it. Today, we will be presenting in Data and People We Trust, building a reliable data platform with Trino and data observability.
Hello, everyone here. My name is Z. I've been a lifelong data engineer since the start of my career. I've worked across various parts of the data land on data infrastructure, data warehousing, and building data products. I joined Assurance late last year to lead data engineering teams here. Now back to Mitch.
Thanks, Z. A little bit about me. I've worked at several startups across varying stages and business models. I started my career in data and analytics, mostly around monitoring, visualization, and analysis, but I've since shifted to data platform and analytics engineering. I came to Assurance early stage, December 2018. There was maybe 70 or 80 employees. And now I'm focused on scaling data operations to our 600 core employees and even into the thousands when we include our broader licensed agent base as well. So before we dive into Trino and data observability, we thought it'd be very important to set some context here. We think that understanding our organization, Assurance, is key to help understand the kinds of data challenges that we face. From there, we wanted to discuss some of the tools and technology that make up our data platform to help us tackle those data challenges. And then we wanted to spend some time covering the new challenges we face now that our organization has continued to scale. And in those challenges, we wanted to share some solutions we tried specifically pertaining to data observability. So the organization, let's start with that. Assurance is an online insurance distribution platform. We are a multi-sided marketplace that represents the interests of individuals who are looking for financial services products, licensed agents who are subject matter experts on these products and can help the shoppers navigate that journey, as well as the carriers or organizations who we partnered with to offer products on our platform. And to understand how it works, we think it's helpful to think of it a little bit like Amazon meets Netflix meets Uber, in that we're like Amazon in that we're a one-stop shop for all these financial services and products. So you can see here we offer life insurance, health insurance, Medicare if you're older, which is a very big line, as well as specific financial products like mortgages or financial loans. We're a bit like Netflix in that we're constantly thinking about our shoppers and what kind of recommendations or personalizations we'd be making for those products. And then a bit like Uber in that we are a multi-sided marketplace and we're constantly trying to balance the supply and demand in the marketplace. So the same way that Uber, you might use it as a rider and it will route you to a driver, the same thing, we're doing the same thing with our shoppers, doing some matchmaking and routing them to our licensed agents who can help them. So some more specific problems that we work on. This is a big one, recommendations throughout the customer buying journey. All along their life cycle, we're picking up data points and using that to kind of craft their experience. So we know what kind of experience they're looking for. Is that telephonic or digital? Who that person actually is, what their demographic and risk profiles look like, where they are along their customer journey, if we think that they're likely to purchase from us or we're the best match for them or perhaps another partner in our marketplace. A number of different factors. In order to make these high quality recommendations, well, we need lots of data. We're doing hundreds of thousands, even millions of predictions per day in some cases. And in order to do that, we need tons of data and really sophisticated data infrastructure as well. And I'm going to pass it over to Z to share some details about our data platform.
Cool. Thanks, Mitch. Our data tech stack here at Assurance is fairly modern. We rely heavily on Trino as our query engine and Spark plus DBQ to handle most of the transformations, while are orchestrated through Airflow with S3-backed storage. Our data is lastly served to Looker Tableau for consumption, while we utilize Monte Carlo data to serve as our observability and reliability platform. We consider ourselves to be very data-driven, both from a technology and also people perspective. A bit of history. Assurance started off as a bit of a very data-centric organization. Many of our early hires were data scientists and data engineers. Our CEO, Allison, was our first data hire and was our chief data scientist. I'm very proud to say data is baked into our DNA. Mitch will now give a bit of more history of data at Assurance.
Thanks, C. So some context here. If we look back to the summer of 2021, you can see on that screenshot there, that was me giving the customer lightning talk at Starburst's Data Nova for data scientists. And there we shared how our lakehouse really enabled us to move quickly to keep up with the pace of business change. But now if we fast forward a few years, our company has scaled significantly. We've 5x'd our headcount in just a few short years. You can see there our data headcount hasn't grown 5x, it's actually grown sublinearly to the broader organization. We are being efficient in our data hires, but still there's a ton of stakeholders are asking many different kinds of questions, and we have more contributors on our platform as well. So observability is just more critical for us to us than ever. And if we think about that a little bit more, it's the data variety that's coming in as the business is rapidly changing. And as we bring on more data contributors, that transformation complexity is starting to proliferate. So we really needed a way to see, inspect, and alert to what was happening within our data platform, kind of end to end. And additionally, for us, we need to meet regulatory requirements for our industry. In insurance and financial services, it's very important to protect consumers' information, and regulators really require proof that we are able to see where data is coming from, what we're doing to it, and then how it is actually being used in all these different use cases as well. So that brings us to sort of the main topic here, that road to data observability. If you're attending this talk today, you're likely very interested in being able to see what is going on in your organization with respect to data. And we wanted to share some insights and learnings on how we think that you could actually kickstart and scale up a data observability program. And we strongly believe that it comes down to three major factors. And it's important to think of them or kind of roll this out in this linear fashion, and that you want to start with the people, then think about some of those processes for data observability, and then think about the tools and technology that would actually help you implement such a program. So the first thing about any great data observability program, it really comes down to the importance of quality data. So for us, we went to the literature here. You can see this O'Reilly text about data quality fundamentals to look at some of those definitions, or how others are thinking about quality data. And they define it as the health of data at any point in its life cycle. And that would be a function of measuring different factors of it. So that could be its reliability, its completeness, or its accuracy as it relates to the state of what is being reported on. And that data quality, it's a very powerful way to understand whether your data is fitting the needs of your business. And it's the observability program that you can roll out that will help you understand whether you are meeting this sort of idea of quality data. But the thing is, for each organization, that idea of quality data and observing whether it's quality, it's going to be a little bit different. And to kickstart your data observability initiative, it really starts with finding your why. We strongly believe that any initiative here is going to struggle to gain traction if there's no clear reason or incentive for doing so. So we think that the people within the organization must decide as an organization why quality data matters to them, define what those standards might be, and then collectively commit to them, almost as if it's a contract. Data contracts are a really hot topic in the space, for example, and kind of taking that step and thinking about the idea of a contract, a mutual agreement, sort of collectively for your organization. It really starts here. It starts with the why. If you can't trust the data and the products it's powering, then how can your data users trust your team to deliver value? So we thought of some sample questions to kickstart an observability initiative. By no means an exhaustive list, but if you want to get to that why, it's like you got to think about what kind of negative impacts you might expect if a stakeholder decided off of inaccurate data. Let's say a pipeline went down, you didn't have observability set up, you couldn't see this, you weren't alerted to it. Well, then a stakeholder might make a decision that results in a huge revenue loss for your organization. And if you think about your team, your data team and those operations, it's helpful to think about the labor hours and actual salary and wages that are going towards reactive cleanup due to data quality issues. If you're spending a lot of time there, it's an opportunity cost on working on higher value projects that could deliver more value to your organization. And then another way to think about this as well is, what kind of impact would your organization feel if users did not trust the data platform and they were using alternative methods that were not observed at all? What does that loss of trust mean for your data team? It's really something important to consider. So with that, part one down, finding your why, we can now start thinking about part two and get a little more specific and put that pen to paper with the people defining what data quality means to them and agreeing to uphold these standards. So we've put together a few ideas, by no means an exhaustive list either, but just something to kind of get your gears turning. But if you think about attributes of quality data and how you might observe them, we can really think about a few things here. One is visibility. Can users visually see where data is flowing and its context in the broader organization? Accountability is super important. Can users of your data platform know who is responsible for any given data asset? Are there minimum standards or agreements and objectives that are known for these assets? Is data documented? Are descriptions about data, where it comes from, how it's transformed, and what people need to know to use it effectively? Is that written and accessible and visible to others? And another factor we can think of is enforceability. It's great if you have visibility, accountability, and documentation, but is it possible for those standards to actually be enforced via some process? And can users see whether those standards of high quality are actually being met? So here, once we've documented this down, we can start thinking about the processes that actually start changing behavior and data culture with respect to high quality data and observing it. So here we can see, if you want data to be visible, well, then ideally your contributors are developing on tools and technology that can connect to some kind of established lineage graph that tracks how data is flowing and moving through the organization. If you want accountability, some kind of supporting process could be grouping your contributors into domains, assigning them ownership over specific assets that they're producing, and then defining those standards for those assets. If you want documented data, you're going to need to incorporate documentation into the actual development process. Contributors should be able to document data and write checks for them along those factors in terms of accuracy, reliability, and completeness as the data is created and modified. And if we're talking about enforceability, ideally there are some kind of alerts that are sent out to domains. There's some kind of standard operating procedure to triage and resolve those alerts. There ideally is a method to review their adherence to those standards on a regular basis. And if you want to be more sophisticated, potentially you could implement a process where data asset changes are not deployed until you have documentation and tests detected. So these are just some examples of how you can think about observability and data quality and what kind of processes you'd have in place to support it. And once you have those down, then you can start thinking about the technology, where you can pick a tool that has features for your attributes, descriptions, and processes. And with that, I'm going to hand it over to Z to explain a little bit more about the solutions that we've tried in this space.
Thanks, Mitch. I'm going to walk us through some common scenarios of how we at Assurance utilize Monte Carlo to solve observability and reliability challenges. In summary, we use Monte Carlo to keep us well informed around what is happening in our data land. You'll hear about how we use Monte Carlo to catch unexpected events in data, and how we build and benefit using Monte Carlo's data lineage feature, and lastly, on how we codify all of these above. I'm not a big fan of surprises, especially in a professional setting. With my career working as a data engineer and leading data engineering teams, a lot of my time was spent dealing with surprises coming from upstream, while avoiding giving surprises to my fellow downstream partners. As we stated in the title of the presentation, is in data and people we trust. So what is surprising data? I'm really referring to common scenarios like schema changes from ingestion sources or other data sets that we data engineers ingest from, and all other types of data anomalies, such as getting too many null values in the table, or finding a row that says a customer of age of -35, or in our case, an insurance policy sold for $10 million. I wish that's true. Our goal here is to have an automated and systematic way around us to keep us informed when scenarios like these take place. Ultimately, we want to be able to build trust for us and our customer to trust in our data. With Monte Carlo, we're able to automate the process to catch any unexpected table schema changes, such as addition, removal, or modification of a column, or other changes around the metadata of a dataset. Here we have an example of an alert that we got from Monte Carlo sent to one of our Slack channels. Note this one in particular is regarding a schema change detected in one of our core datasets. Note how a new column is added, query campaign ID, and another column called ID being removed. I may suspect this is a alter table rename column operation. This really prompts our on-call engineer to investigate what may have caused this change. As data owner, being informed on these changes is really helpful to really allow us to take actions to determine what really happened. Once investigated, our on-call engineers is able to categorize this alert being either fixed, expected, false positive, no action needed, or still under investigation. This is all to keep others informed as well. Here's another Slack alert we got from Monte Carlo. In this case, we're getting an anomaly detection triggered. In previous example, we were alerted on changes made to a dataset at metadata level. This one is informing us on something that happened within the dataset itself. In this example, we have a case where a table expected more rows to be ingested, but only received a very tiny addition. Note how it says we typically get about 200,000 rows, but in this case, we got only about 500. Similar to volume alert we see here, there's other types of alerts that we can set up as well, such as freshness alert, that's when you may have a delay in data delivery, or distribution alert, that's when data set skews in an unexpected way. Keeping us alerted on these unexpected changes is really extremely helpful to avoid misconsumption of these data sets to consumers. So how did we enforce these rules? Monte Carlo allows these standards to be defined, monitored, and alerted. Data owners are able to compose and commit custom-fitting data quality checks. This is an example on the screen of how we're able to enforce standards via an automated process in a very configuration-driven manner. Really, the end goal here is to allow data owners and consumers to see whether if the defined standards are being met or not. I mentioned data lineage briefly before. Here's an example of a data lineage map built by Monte Carlo. If you followed my previous slides carefully, by now you should have proper monitor and alert setup so that you're well informed on when things break. But as an engineer myself, I would love to do even better. How do I actually prevent things from breaking? Monte Carlo offers the ability to allow us to gain insights around lineage of a particular dataset, both upstream and downstream. Much of these are automated by embedding data lineage collection logic within your ETL layer, so that any new addition of tables or modification of an existing lineage is all captured by Monte Carlo automatically. Once I have a lineage map built, before I make an attempt to modify an existing dataset, I'm actually able to view my potential blast radius downstream to keep these people informed. This is really a great way to plan out my rollout. We also found data lineage to be extremely helpful when we perform investigative exercises, again, by providing insights to both up and downstream of a dataset. It is important to note that data lineage works beyond just database tables. Monte Carlo supports a wide range of technologies to be connected and included in its data lineage map. Every single one of our technology that we just mentioned prior is supported by Monte Carlo. Now, I want to discuss the topic of accountability. It is crucial to keep data owners accountable for. This gives insights to end users to know who's responsible for data sets they consume. Monte Carlo groups data contributors or owners into domain, in which they own data sets they produce. You can think of a domain in terms of a team. Domain setup is completed through tagging and schema ownership definition. Now, if you ever have a question about a piece of data set, you would know whom to talk to. Here on the screen is an example domain setup we have here at Assurance. Keeping datasets documented is another equally important step in building trust with data. Monte Carlo enables data contributors to add descriptions around where the data came from, how it is transformed, and anything else that the data consumer may find helpful, ultimately allowing end users to know the best way to effectively make use of these datasets. Lastly, being a data person, who doesn't love to see data about their data? Monte Carlo provides the aggregated metrics on a per domain level for all assets under such domain. For example, you're able to view the size of your data lake, number of reports, dashboards you own, or performance metrics such as how many freshness or volume alerts your data sets received over a period of time. These data points empower both data owners and consumers to visually see how their data sets perform from time to time, and to take any action upon a trend that's going into the wrong direction. So better yet, we're able to codify all of these above that I just mentioned. Codification has been the new buzzword in the software industry. You have infrastructure codified, configuration codified. Now you can actually have data anomaly detection monitors and alerts codified as well. On the screen, we have an example of how we codified a piece of our alert in YAML. My favorite analogy for monitors alerts is to think of them as the unit test equivalent in data world. Just like our friends on software engineering side, production-grade datasets should have a fair degree of coverage of monitors and alerts in place to ensure quality, reliability, and to build trust. Now, we should all ask ourselves this question: does my dataset have the proper amount of monitor and alert coverage? Now, let me pass it back to my colleague Mish to discuss some of the next steps.
Thanks, Z. So we just gave an overview of our data observability program and how we were using Monte Carlo to actually check off and succeed on implementing those processes that we defined in the sort of document outline of what our people all agreed upon was high quality data. But it's by no means complete. This is a continuous journey, as I'm sure anyone else doing a data observability program would tell you. So for what's next for us, we're really looking at targeting 100% Monte Carlo coverage for our core data assets. That includes alerts and monitors, as well as data lineage integration. There's a few upgrades we can make on our end to kind of complete our lineage map end to end. And once we've accomplished that, we think we can drive more contributions of data quality and adoption and self-serve lineage tools in the broader organization. We've had some success internally within our data teams adopting this tool and using the data observability program. But we think that there's more opportunity having the broader organization get on board with this as well, so that they're capable of looking up data, seeing that documentation and understanding how it's used so that they can go about and complete their day-to-day tasks without taking up additional data team resources, asking where this came from and what this column means, et cetera. And for us, we think that another superpower we could get from our data observability program here is some more automation. So we really want to implement some CI/CD checks to block deploys if they're failing to meet minimum data quality standards. For example, if you tried to do a PR that didn't have any tests or documentation on a critical data asset, we would actually stop that from going through until the checks are met. Additionally, there are some more integrations we really want to deploy as well. dbt and Monte Carlo have a great integration where you could take documentation written in dbt's YAML files and actually pipe it straight through to your Monte Carlo assets. That would really empower your developers and contributors such that they only have to write definitions and documentation once, and it just flows through to the system, really building out that robust observability program. So with that, this concludes the presentation. Thanks very much for attending. We're always ready to chat data, ops, anything else, and we are hiring, so please get in touch. Our careers page is listed down there at the bottom. And with that, we can open up the floor for questions. Thanks very much.